today we will be discussing about the sampling distribution and also sampling distribution of means of samples chosen from a normal population. So let's first have a look at what a sampling distribution is all about. Now let us consider some random samples from a normal population, that is let x1, x2, etc. xn be a random sample taken from a normal population. Now let's consider a statistic which is a function of this random sample which is taken from the population. Now here I'm going to denote the statistic as t, which is equal to, as I said, it is a function of the random sample which is taken from the population. So t is equal to f of x1, x2, etc. xn. Now here the t or the statistic is a measurable function of the sample values, and it is also a random variable. Now the distribution of the statistic or the distribution of t is called as the sampling distribution, or we say it as the distribution of a statistic. Now the sampling distribution play a very important role in statistical inference, but the determination of sampling distribution in general is not a very easy job. The problem has been solved only in the case of a limited number of statistics. So let's have a look at the sampling distribution of means of the sample taken from a. Now let x1, x2, etc. up to xn be random samples taken from a normal population. Okay, now we are asked to find out the distribution of x bar. Okay, now we are asked to find out the distribution of x bar. Now what is x bar? X bar is equal to x1 plus x2 plus etc. plus xn, the whole divided by what? N. Okay, so here we have the information that our samples are taken from a normal population. That means xi's in general, xi's follows a normal population with mean mu and standard deviation sigma. Now we are asked to find out the distribution of x bar. So in order to find out the distribution of x bar, what we have to do is we can take the method of finding the MGF of x bar, and we can check whether the MGF of x bar is similar or it resembles similar to any MGF which we have studied in our last semester. Okay, any MGF of any distribution that we have studied. So if you find a similarity between the MGF of x bar, and if it is similar to the MGF of any distribution that we have studied in the last semester, then we can say that x bar follows that particular distribution. Okay, so let's have a look at how we will arrive. So since we know that xi's are, as I said earlier, xi's follows a normal distribution, the MGF of xi will be what? E raised to mu t plus t square sigma square by t square sigma square by 2. Right, just a second. T square sigma square divided by 2. Okay, for I is equal to 1, 2, 3, etc. up to n. Now that is empty xi. Now let's have a look at, we have to find out what? The MGF of x bar. Now what is the MGF of x bar? How can you write that? M x1 plus x2 plus etc. plus xn divided by n t. Okay, you can write this like that in this format also, which is again equal to m etc. m t by n xn. Okay, now what is mt by n x1? What is mtx? E raised to mu t plus t square sigma square by n. Now what is mt by n x1? It is nothing but e raised to mu t by n plus t square sigma square divided by 2n square. Okay, multiplied by, what about this? The same, e raised to mu t by n plus t square sigma square by 2n square multiplied by etc. So we have n times these, each of these terms are n times. So how will I consolidate it? I'm going to consolidate it, which is equal to e raised to, since that is n times, you can write it as e raised to mu t by n plus t square sigma square by 2n square the whole raised to n. Okay, now what is that? This is equal to e raised to mu t plus t square sigma square by 2n. Now this is the MGF of, what is this? This is the MGF of x bar. Okay, now do you find any similarity between this MGF and the MGF of a normal distribution? Yes. Now this is also similar to, this is similar to the MGF of a normal distribution, with mean mu and standard deviation sigma by root n. Okay, so in short, what we can say, that x bar follows a normal distribution with mean mu and a standard deviation of sigma by root n. So here what can I write? That sigma square by n. Okay, now standard deviation of sigma by root n. It is sigma by root n. Okay, now what is f of x bar? Then what f of x bar is equal to root n divided by root 2 pi sigma e raised to minus n x bar minus mu the whole square divided by 2 sigma square, where the range of x bar lies between minus infinity and plus infinity. Also, let t be a variable, and you can write t as x bar minus mu into root n divided by sigma. Now what is this? You have studied z is equal to x minus mu by sigma. Similarly, t is equal to x bar minus mu divided by sigma by root n. That root n just came to the denominator. What is that? Yeah, here I am standardizing the random variable x bar. So t is equal to what? A standard normal distribution with mean 0 and standard deviation 1. So t follows normal 0 1. And what is f of t? F of t is equal to 1 by root 2 pi e raised to minus t square divided by 2, where the value of t lies between minus infinity and plus infinity. So from this, what we say that we were asked to find out the sampling distribution of means of samples which is taken from a normal population. So we were asked to find out the distribution of x bar, and the distribution of x bar is what? X bar follows a normal distribution. Okay, so that is our conclusion. Thank you.